All right, thank you everybody for attending. This workshop is brought to you by Crossvale and Red Hat. This is a Containers and Cloud Native workshop. This is our second workshop in our series. Appreciate everybody coming. Hopefully we can teach you something new and you can learn a bit about containers and cloud native. At the end, we can have a question and answer session if you have additional questions or answers, or you can email Crossvale at tmillard that's TMILLARD at crossvale.com. If you have any additional questions after the webinar, that we can follow up with you and make sure that we get your questions answered. Next slide. So why we're having this webinar today is people take a look at the cloud and they kind of see this top picture up here and they go, oh, well, this is pretty easy. Yes, we're just going to release this into the cloud and the app is just going to run like this sweet little bird here. But what enterprises find out in the journey is it really is more of this dragon that they're trying to wrangle to get everything working the way that they need to do. And that's where Red Hat comes in to really help with some platforms that can greatly reduce this dragon, and also services from organizations like Crossvale that have team members that can come in and help you understand how to get your system admins to do what they need to do, how to get your senior developers to understand the things that are going to help that dragon be more of the bird. Cloud architects understand better after, they start getting this, getting into this cloud journey. So what we're here today is to try to help you understand some of the differences between what the perception is of this easy release it into the cloud, and then what the actual dragon looks like, and then how to make that simpler for you. Next slide. So today's workshop, we'll do a little bit of company intro so you know who Crossvale is, so why we're the one sitting here doing this workshop. Then we'll do an introduction to the Cloud Native series, which Marcos Rivas, our consultant, will go through that with you and commence the workshop 2, and then conclusions and wrap up, and then we will close. So this is what our agenda looks like today between now and 2 hours from now, or 3 hours from now. So Crossvale, who is Crossvale? Crossvale is a Red Hat Apex Premier partner. So we've been working with Red Hat for many years as a services partner to help customers get more out of their platforms. And so we do services and focus on managed services, professional services, as well as subscriptions, and helping you get more out of your Red Hat platforms. Next slide. So what we do is we focus on helping you rethink digital transformation. Everybody's out there trying to find out how they can get better value out of their data. And what Crossvale brings to the table is we understand holistically from the infrastructure, the DevOps, and the application, and actually operations side of your IT, how to get the most out of your Red Hat platforms. And if you're looking at digitally transforming, trying to modernize, trying to move towards hybrid, instead of reinventing the wheel, bringing somebody in like Red Hat and Crossvale, we can help you get your ROI way faster than you will on your own. And that's why we're here today, to talk to you a bit about some of the aspects of that from a platform perspective. Move forward. So Crossvale takes a look at your environments in 3 different ways. We focus on automation, hybrid cloud, and your software development lifecycle modernization. We find there's a lot of places that you can focus on, but we find customers that we work with get the most value out of focusing on automation. How do they then move applications to hybrid cloud so they can get the most out of cloud native development and the self-service aspects of the cloud, and also have access to all of the things that cloud will provide with the integrations that are available out there, as well as then modernizing your SDLC. So that way your software development life cycle matches what your agile processes are, so that your business can get more done faster. The idea here is to enable business through IT, so business can do more quicker and can respond faster to the customers, which gives you more revenue and more profitability. So the business is actually using IT as a way to drive revenue, not as a cost center. Move forward. As a Red Hat partner, we have won multiple awards: 2018, 2019, 2020, 2021, Red Hat Partner of the Year for a number of different things that we do. What it really comes down to, as a services partner, there's a lot of partners out there that help Red Hat, but we are really focused around making sure that the platforms that we sell from a subscription standpoint, we have consultants and resources to be able to help you understand how to maximize those and get the most out of the platform. And that's what we bring to the table to help you with your modernization. Next slide. So we focus this in 3 different areas. So we have the day 0, where we can come in and help from a strategic standpoint, help you architect your solutions, help you understand how to design the things that you need to do from a modernization aspect. We actually have modernization journeys to help through automation, hybrid cloud, as well as SDLC. And we also have a focused automation journey around microservices for people that are taking legacy apps and moving to microservices. So this is an area where upfront we can help do an assessment, take a look at everything you have going on in your environment, come back with, here is the best way to capitalize on what you have and move forward with what your goals are. Move forward. Next slide is day 1. So in the day 1 aspect, we are able to come in and help side by side develop in a pair programming situation, or we can actually bring in teams with blended rates with offshore resources that in most cases we can help you develop faster and cheaper than you can do it on your own, and help augment your team in that way. And day 2, we also have a managed service division where we will actually manage whatever we build for you. So we do a lot of Openshift management, where we come in, especially for customers that have high compliance requirements and need to have somebody be able to handle the low-level tasks so that your people can focus on the high-level tasks. We have a great team that's award-winning to help you solve that problem. And we can definitely do that cheaper than you can 24/7, 365, and we do that worldwide. Next slide. What, where, and how, and when. So we have offices in the UK, Spain, and US. So this is how we cover the areas that we focus on. So we focus in the Americas and Europe, Africa, Middle East. Have done a little bit over in Asia Pac if you have any needs over there, because we do have worldwide customers. But you know, we run our Asia Pac out of the UK at this point. And that contact information is me that's on there, Todd Millard. I am the Chief Growth Officer for Crossvale. So here is a list of the upcoming events that we have. So go to the next slide. So today we're focused on container and cloud native, the Cloud Native Roadshow Workshop 2. So this is in the Openshift series that Crossvale is doing with Red Hat. So this is our second workshop. If you are interested in seeing our first workshop, we do have that out there on YouTube, and we can send you the link for that. Please just give us a chat or send us an email saying you'd like to see the first workshop. I'll go through what the first workshop was to see if that's something of interest on the next slide, I believe. Yep. So the first workshop we did in early August, which was migrating workloads. So if that's something that you have some interest after seeing the workshop we're focused on today, which is automating pipelines with CI/CD, we could definitely get you access to that workshop. Next in September, we will be doing service mesh. This is an area that there's a lot of interest around in how to maximize what you're doing inside your clusters using a service mesh. So this will be a really interesting workshop if you're looking at migrating and you need to refactor and understand how you can make things work the best for you inside your clusters. Then we have event-driven serverless. So this is another area that there's a lot of interest in. How do I take my legacy apps and how do I maximize the amount of infrastructure that I need and reduce the amount of compute? Serverless can help with that. We can help you understand how to get from where you're at now to where you need to be. And then we will have a the final one is the customized bespoke workshop. And so we still have some dates to pick on the upcoming ones, but we will make sure that you guys get those dates as those are announced, and move forward. So now I'm going to turn this over to, well, before I turn this over to Marcos Rivas, a little bit of housekeeping. So you're muted. We are recording this. If you use the Q&A for any questions, and there is a chat in there as well. If you guys, again, we love to have some questions. If you have some questions where we need to, get back with you and maybe help you understand how some of the things that we're teaching today can work inside your environment. We know everybody's a snowflake. There's no one size fits all. There's always some things that we need to do to figure out how to take what the incredible platforms Red Hat makes and how to fit that into your environment in a way that you're going to maximize it. So please reach out, ask questions if you have questions. So now I'm going to turn over to Marcos Rivas, which is going to kick off the technical part of our workshop here. I hope the business part didn't bore you to death, but I would love to hear from you guys if you have any questions or feedback. So Marcos, over to you.
Thank you, Todd. My name is Marcos Rivas. I'm going to be your technical guide through this workshop. Today, we are not only going to do continuous delivery, we are going to overcome some of the challenges that a cloud architecture has, like monitoring or tracing. Because when you have a new innovation model, you have new challenges and also new benefits. What we want to have is an application running a microservice architecture. And in order to do that, we need a platform and we need a cloud infrastructure to provide that agility and that auto-scaling that we may need for our applications. In order to achieve this cloud native architecture from a legacy architecture, we will need to follow a path that will have to mean to adopt a DevOps culture, to try to automate everything as possible, and also to try to do continuous delivery and also advanced deployment techniques like blue-green deployment or canary deployment. This will lead to a microservice architecture or to a fast monolith architecture. This means that all over the stack can be able to deploy a monolith as fast as a microservice. In order to do this, Red Hat provides the Openshift Platform, which is a Kubernetes customization that allows some of the operation to be done more easily than in Kubernetes. And it also has some Red Hat middleware solutions that can run in Openshift that solves a lot of problems, like, for example, the monitoring problem. There are some solutions that run in Openshift that are able to monitor all the applications that are running in Openshift. And in order to develop those applications, Red Hat provides the Red Hat Code Ready Studio, which is an integrated development environment that allows developers to develop faster to Openshift. So first of all, this is not going to be an Openshift 101 workshop. We are going to develop on Openshift, but we want to cover a little bit of the basic of the platform. So Openshift 4 is based on Kubernetes, and it has some extensions on top of Kubernetes. It runs on CoreOS, and it also has some automated operators that allows some operations to be done more easily, like service mesh or monitoring, or, for example, authentication. It is also possible to use the Red Hat stack to deploy applications and services into the cluster more easily. This means that developers can be more productive in their day-to-day because all the stack enables the developers to have a faster development lifecycle and to reduce the human-prone errors due to the automation stack in the deployment and in the continuous integration. There are multiple languages support. Today we are going to cover Java-based frameworks, but there are some other languages. And also we are going to do a continuous delivery pipeline that is going to promote an application to a production environment. And we are going also to monitor the application resource consumption and also the application request tracing, which is something very important in a distributed architecture. So when you're building next-gen applications, you will have, as I said, some challenges, and we will need to install and to use some tools that in a traditional architecture were not needed. For example, we will need a service mesh that is going to be covered in the next workshop in order to cover the network layer of the microservices, because there are a lot of microservices. It's not in a legacy architecture in which we may have a few services running. In this case, it could be up to 100 of microservices running. There is also some Openshift serverless functions, like for example, CamelK, which enables the development of integration solutions without having to program a service, which means that the development time of a new feature, of a new solution, is going to be much faster, since the developer only has to focus in the code, not in all the platform or all the container that the application is running on. So when an application changes from monolith to microservices, it means that we need to change the way that we develop applications. Traditionally, we could do waterfall deployments because monolith has a lot of features and a lot of integration, and it's already coupled between one component and another. When we move to a microservice architecture, it enables us to have an agile methodology, which means that we can have faster deployment and we can have faster deployment processes, and also it is possible for a developer to implement a new service and to change it in an isolated way that doesn't impact the other services. In order to do this, the key is the container. So the container is the environment in which our application is running. On top of it, each application needs a container to run. The container will be running in a pod, which is the unit that we need to deploy to the Openshift cluster. But the application will be running inside a container, and to do containers is very hard because we need to manage a lot of containers. And without a platform that containers are being executed on, it is very difficult to run the containers, to stop a container, to scale automatically a container, because there are more of them, which means there are a lot of human interactions and a lot of commands to be used in order to manage all those containers. The platform does some of that management for us. So with some YAML manifest, it is possible to specify which number of containers we want for an application, or when do we want an application to scale, or to scale up or to scale down. This enables developers to focus on what's in on the container. All the other problems, how many containers are running, how many resources is the container consuming, this is going to be configured at a platform level, not at an application level, which means that the developer can focus on the code, on what is on the container, what really matters, and it is what it really has a value for our clients. So as I said, having a microservice architecture is hard, and it also comes with some challenges, like for example, deployment. In a traditional architecture, there could be a few application services in which we deploy a WAR file. So it could be done manually, or some of the part could be done manually. In a microservice architecture, that is not possible because because of the amount of microservices that need to be managed. It also comes with another challenges, like for example, monitoring. We don't need to monitor the CPU consumption of one application server. We'll need to monitor the consumption of each of the containers that is running in our platform, which could be up to hundreds of containers. So to install a monitoring tool in the platform that is able to show in a graphical way, in a web UI, the consumption of each of the containers, and also, for example, the consumption in the cluster overall is very useful for an administrator. Also, one thing to consider is the tracing of incoming requests. When you have multiple microservices, it is not possible to foresee which microservice the request is going to hit because there are multiple replicas running and the number of replicas changes over time. So with a tracing solution, we can trace a request from which it goes into the cluster until it goes out of the cluster. And we can see how much time it spends in each of the services involved in the transaction. As I said, it also has a lot of benefits, like an improved scalability. First of all, a microservice is smaller than a monolith. It means that it's going to be faster to start. And that means that it's going to be faster to scale up in terms of, for example, to meet a high peak of load. It is possible to configure the number of replicas based on the incoming load of a container. So the container, if a lot of requests are going in, it is able to scale up, and it is able to scale up in a very fast way, in a much faster way than with the monolith. It also means that since microservices are small, features can be deployed faster because a microservice is easier to change and it's easier to develop on. It has less code to change, it has less code to validate. So it means that can be deployed faster. So in the workshop today, we are going to use some tools to overcome these challenges. First of all, we are going to use Openshift pipelines by using a Jenkins file to promote an application from one environment to another. We are going also to use Prometheus to deploy and to expose Prometheus metrics in an application, and to configure a web UI with those panels to see the metrics that we have configured in the application. And as a tracing solution, we are going to deploy Jagger in Openshift, and we're going to configure an application to report its incoming request to the tracing tool. So the continuous delivery, it is what we can see on this image. We will have a dev namespace and we'll have a prod namespace. And we will implement a promotion pipeline that takes the container from the dev namespace and moves it to the prod namespace. For the tracing solution, we're going to implement Jagger, which is a web UI that is able to trace all the incoming requests of a service. As you can see in this image, for example, we can see that this particular request has a 2.2 milliseconds response time in the container itself. And finally, we're going to configure Grafana so we can have a dashboard like the one I am showing in the screen, in which we can see the memory being consumed by an application and, for example, the number of messages that is also processing. So we are going to start with the hands-on workshop. First of all, and before we start, make sure that you are registered so you can see you can log in the workshop workspace, and also check all the guides and check everything that you need to start. Let me get, okay, so you will need to access this URL. I'm going to paste it on the chat. And the password is Red Hat one with an exclamation sign at the end. Okay, so when you register, I'm going to share my screen again. So, oh, sorry, this. When you are registered in the workshop, you will have access to the Openshift console with your username and password, which in my case is, well, first of all, this is the Openshift console URI. Let me paste it on the chat. Openshift console. This is the Openshift console. Your username is going to be your user, which in my case is user1, and Red Hat 1 exclamation sign. So you will have a customized namespaces for you to do the workshop on. I'm going to skip the tool for now. And you also have access to the code ready namespace, which is an integrated IDE in which we can do the development with the same environment as I will be doing. Mind that this workshop could be done in a an code ready IDE, which is Eclipse based, not in this, which is based on Eclipse Che. But if we are going to use the code ready workspace, it means that we are all going to start with the same environment. Okay, first of all, I'm going to share also the guide. So if anyone gets lost, or if anyone wants to do the workshop after this session is finished, there is a guide here in which you can check all the information that you need. I am going to do the workshop manually, but feel free to follow the guide and to ask me any questions you may have. So first of all, this is the code ready workspace console, and you need to click here to start the workspace, and it is going to start. It is a web IDE, so it will have some or it may have some problems that it means that we have to refresh sometimes the IDE. Okay, so this is similar to a Visual Studio, but online. Here we can see that we have a file explorer or a source code management tool or a debugging tool. And we, first of all, what we are going to do is we are going to clone the repository. This is the repository for module 2. So we only need to click git clone and paste the URL that I pasted on the chat. And yeah, projects, for example. And it is going to clone the IDE that it has 4 folders on it. Before I continue, I am going to validate that the branch that we have downloaded is correct. Mind that we are going to be using OpenShift 4.7 version, which means that the branch of the repository should be OCP 4.7. In order to check that, you can check in the right menu, this cube here, and click New Terminal. And a new terminal will be opened, which is standard terminal. And if we do git branch, I can see that I am on OpenShift 4.7 branch. So there will be no problem with that because we are on the correct branch. Okay. Second of all, we are going to log into Openshift. There is this tool here below, just below New Terminal, which is login to Openshift. And if we click that, it is going to do an OC login into the Openshift cluster that we have for this workshop. And I can see that I have been logging successfully. So if I close this tab, and back in the terminal, I'll do an OpenShift command like who am I, for example, I am user1. Okay, so the code-ready workspace is ready. And what we need to do now is to start or to reproduce the steps that we did on module 1. In order to do this, we will need to execute some scripts. I'm going to paste it on the chat. This is what we need to execute. And this is going to deploy all the workloads that we implemented on module 1 are going to be configured to start module 2. It means that it's going to deploy a Quarkus and a Spring Boot application, and it is also going to deploy a JBoss application. Okay, so if we go back to the Openshift cluster now, we should see that something is start to change. Okay, so we have an inventory. Yeah, it is loading yet. Okay, now we have, it is starting to create a database and it is starting to deploy all the applications. Yeah, it will need to basically build the applications and deploy it to Openshift. And since everything that runs in Openshift can be expressed in a YAML file, it is very easy to have that file in a repository or somewhere in which you can take it and apply it to an Openshift cluster, and your application environment will be exactly the same as it was before. Basically, this is what it's doing. It's going to build the application, it's going to create an image, and it's going to take a YAML and it's going to deploy it to this particular Openshift cluster. Is, for example, we check the, going to change the view, and yeah, so it has not deployed the application yet, so we will need to wait a little bit until everything is deployed in the cluster. Okay. So right now it is building an image and it is deploying the catalog application. Okay, so while this is implementing the or deploying the catalog application, we can check the inventory application. So if you remember correctly, for module 1, the inventory application was a Quarkus application running on the JVM, and it has a database. So it is a microservice that was embedded on the old monolith service that we refactor and move it to the Quarkus framework in order to have the microservice running. This is already running because, as you can see, there is a dark blue in the Quarkus inventory application and also in the database, which means that if I go to the application, it is running correctly. If we go to the catalog now, it only has a database, so it is deploying. Yeah, it is creating the image for the catalog application. As you can see, this is basically how the image is being built, and in a few moments the application will be, yeah, it is now starting to be deployed here. So the same as the inventory application, the catalog application was a service that the monolith application had implemented, but we refactor that into a Spring Boot microservice instead of a Quarkus microservice. Seems to be down. To try again. Yeah, now it's working. Okay, so the only thing that we have left to deploy is the cool store application itself. But while this is being deployed, we can go ahead and create the production namespace. So we can go to here, and we click create project, and we are going to name it user1 cool store, but instead of being dev, cool store, instead of being dev is going to be prod, which to stand for production namespace, and we can click create. And we will need to deploy application resources. So if now we are on the cool store prod namespace, if we click from catalog and we try to find cool store, we need to use cool store monolith using pipelines. So we click here, we click install template, and we will need to, we are going to specify user1 in the user ID, and make sure that we are using the prod namespace. So if we leave everything as default and we click create, it will deploy, for example, the database and also a deployment config with no application running. So now what we need to do is, what we are going to do is we are going to configure a Jenkins pipeline that is going to take the application that is running here in the cool store dev namespace and is going to move it to the cool store prod namespace. In order to do that, what we need to do is we need to deploy a Jenkins instance. So we can go here to add and click from catalog again and just click Jenkins. And we're going to take the ephemeral solution instead of the persistent. And we are going to increase the memory limit to 2 gigs of memory. And also in this flag, disable memory intensive administrative monitors. We are going to say true. And we are going to click create. So this is going to deploy a Jenkins server in our namespace. And now what we need to do is we need to promote the application. So as part of the template that we have deployed, a monolith pipeline has been created. A pipeline in Openshift, a Jenkins pipeline in Openshift, is a build configuration, but with some particularities. Like, for example, if you go to the YAML, you can see that the strategy is Jenkins pipeline, and it has a Jenkins file embedded. It is also possible to upload the Jenkins file to a Git repository and to specify in this particular Jenkins pipeline scenario the path within a Git repository in which the Jenkins file is stored. So it is not needed to have one Jenkins file per pipeline. It can be shared. Okay, so if we look closely to this pipeline, it is going to simulate the build and the unit test deployment, but we only care about the promotion. The promotion, as you can see here, is doing an Openshift tag command, which means that it is going to take the image that is tagged with latest in the user1 call store dev namespace, and it is going to create the image into the prod namespace with the prod tag. So if, for example, we go to the dev namespace and we check the image streams, which are on the administrator view on builds and builds image stream, we can see that there is an image which is latest. So this particular image, which has the latest tag, is the one that is going to be promoted to prod when the pipeline is executed. So if we go back to the prod namespace and to the build config, the only thing that we need to do here is to click Actions and Start Build. The build is going to be done in Jenkins. Although it is an OpenShift build config, there is a synchronization plugin that is able to synchronize Jenkins jobs with OpenShift builds. And it is already starting. So we could log in Jenkins, and we can see the Jenkins job as a standard Jenkins job. And we could start the job from here, or we can do any configuration we may need. Okay, so right now the application should be already deployed in prod. So yeah, it seems that something is running. It's starting. It's not ready yet. Okay, so it is already started. So we need to check if the application is running. So we go to the URL and the application is running in prod. So what we did basically was to create a new image string to the very same image that we had running into the dev namespace, which means that that particular image has been built only once and is now being promoted to a different namespace or to a different environment. In terms of pipeline configuration, it is also possible to modify this pipeline as we would modify a Jenkins pipeline. So for example, if I want to add a stage here that is going to be approve go live, so it requires an approval before the application is promoted to prod. I can do it with the same syntax as in a Jenkins pipeline. So I add the steps here, and I add a timeout parameter, which is going to be 30 minutes because we don't want it to time out. And we will need also to specify that it is an input that is going to be go live in prod, which means that we are going to switch to the new version. Okay, there is no difference between this Jenkins file and a Jenkins file we will implement in a standard Jenkins server. The difference is that the Jenkins that we are deploying in OpenShift has some configurations that allow us to log into the OpenShift cluster and to synchronize the jobs and the OpenShift builds between Jenkins and the OpenShift cluster. So if I click save now, I can see that this is already here. So if I go, for example, to Jenkins and I try to build now, it should ask when it's reached the stage that we have included, it should ask for confirmation that we should promote to production. One thing to consider when doing this configuration, okay, it is already asking me. If we go now to the pods that are running in this namespace, we can see that it's a Maven something pod running. This is the Jenkins agent in which the pipeline is being executed. So it means that when this approve go live is waiting, we will have a Jenkins pod created here that is waiting for our input to continue. If we don't want this to happen, we will need to configure the stage to not to run that approval stage in a Jenkins agent and to run it in the Jenkins master, for example. So we'll keep proceed, for example, and it will continue with the Jenkins pipeline as usual. So now we are going to do a small change to the application, and we're going to promote it to prod. So if we go to the code ready workspaces again, and we go to the monolith, and we try to find on source web app CSS, there's a coolstore.css file, and we're going to change the background of the header. So we're going to include navbar header that is going to have a background color blue. And now what we need to do is we need to deploy this application, to build and deploy this application. So on the terminal, we can go to the monolith folder, and we need to execute a Maven clean package. It is important to specify the profile Openshift, because this is what is going to build our WAR file correctly. And also I am going to skip the tests. So this WAR that is going to be built now, which is on deployments, should be a new one. Let me check. Yeah. So this WAR file has the CSS change inside. So if we now change to the catalog project, not to the cool store, sorry, to the cool store dev project, and we check the build configurations, there is a build of type binary that is called cool store. So this WAR file with this particular change, we are going to deploy it to the dev environment. So we want to start a build of the cool store, and then we need to specify from file deployment. No, I already in the deployments folder, so root.war, and follow so we can see the logs. Okay, with a mistake, start. This is going to build the container image with our new WAR file with the background change on it, and it is going to deploy it to the dev namespace. So if we go back to the Openshift view, developer perspective, and we check the dev namespace, nothing has changed yet, because on the build there should be something in progress. It is running. So when this build is finished, which we can see on the terminal output here, it is about to finish. When that build is finished, that WAR file is going to be deployed into the dev namespace with hopefully the change that we just did on the coolstore.css file. Okay, so build should be finished now, and if we go to the topology view, we can see that it is starting to be deployed. Okay. So we will wait until the circle becomes dark blue. Light blue, it means that the application is being started. Okay, so now we click the link here, and we can see that the navigation bar is now with a blue background. But if I go to the prod application, it should be black. So in order to promote this change to prod, we can go, we will need to go back to Jenkins, and on this monolith pipeline that we have created, we click build now. Okay, so we go to the output, and now it should ask for our confirmation to proceed the deployment to prod of this particular change. Okay. Okay, so we proceed with the deployment. And now if we go to the prod namespace here, it is starting a deployment again. So it means that the image has been promoted to prod. Okay, let's wait until it becomes dark blue. In this scenario, we're doing basically a delivery pipeline while delivering the changes from dev to prod. So now in prod, maybe we have something cached. Let's check. Yeah. Okay. So, but the Openshift pipelines are not limited to the continuous delivery. It is also possible to build an application or to have custom deployment resources and to apply it with the pipeline. But everything is similar to what we just did. The only thing that we need is a pipeline with a Jenkins file on it, with the stages that we need to execute, and that is all that we need to run our pipeline in Openshift. So now that we have promoted a change from a dev namespace to a prod namespace, one thing to consider, or one thing that we didn't cover in the first module, is how to debug with the Red Hat code ready workspaces. And it is something that as a developer is very useful, because we can see what is running in an application and how is the application executing some of its logic. So in order to enable this, I'm going to go to the inventory application, and I am going to run a Maven command. So Maven Quarkus dev, and I'm going to enable debugging for this particular application. So quarkus.http.host equals everything. Okay. If you see, it is started listening on the port 5005, which means that the debugging is enabled in this application. And if we want to debug the application, the only thing that we need to do is to do a request to the application. So I'm going to close this Maven command, and I am going to add something to the application that we can check why it is failing. So on the inventory application, I will go and change the inventory resource, which should be on here. Okay, I am going to add one resource method. It's going to be a get. The path is going to be last letter, and then one path parameter, which is going to be item ID. And we are going to return in this test, we are going to return a text application text plain, and just public method that returns a string, and its name is going to be last letter. Yeah, last letter. And we need to include the path param item ID, which is going to be a string. I'm going to call it item ID. Going to return null for now. Okay, so what we are going to do is that we are going to get a result from the database. So inventory.find, and we're going to find by item ID, and the value is going to be whatever is on the URL, and just return the first one that it is found. We assign this to an inventory item variable, and we are going to get the location of this particular item. So location is item.location, and we are going to return the last letter of the location. So it can be location.substring of location.length. Okay, and we are going to return the last letter. Okay, so now I enable the debugging again. Okay, I did some error. What is the problem? Find the result. Yeah, it's first result, I think. First result. Yeah, should be okay now. Yeah, okay. So if you remember this application, I'm going to open it in a new tab. This application is going to expose a HTTP service in /services inventory. So if I go here, I should see something back. And if I add slash and then last letter, and then some item ID here. Oh, great. Something has failed. Okay. Let's see. Build failed. Why did it fail? Something. I will try again. Last letter, and then one item ID. This one, for example. Yeah, something was wrong with redeploying. So in this case, it is not returning anything. It is empty, the response, because we have, well, the superstring is not being done properly, as we will check right now. So if we want to debug what is happening in this application, we can go to the debug view here, and with attach to app selected, we click the play button. And it is going to start a debugger in our application. Okay, so we can see that there are some threads running. I'm going to add a breakpoint here, and I'm going to do the same request again. What was the last letter? And it is stopped now. In the debug console, you can run statements like, for example, if I do last letter, it prints that it is nothing. So if I check what location is, I can see that is Tokyo for this case. So location.substring should return an O character. So it means that location substring of location.length is returning nothing. And it is correct because it should be length -1, which is a no. So I am going to go ahead. I'm going to resume this execution. And I am going to add -1 here and save. Okay, it should be able now to return an O now. Mind that I have not redeployed, I have not done anything. The debugging Maven command is able to refresh the running application and to change what is running. So at the moment I executed a new request, it returned the last letter of the Tokyo location, which is the item I was trying to find. So this is very powerful when doing when developing. And is something to consider because the refresh of the application while it is running is very fast, and it is also a very nice tool to use with the debug console as well. So I am going to stop now the debugging, and we are going to do some other more Openshift configuration. As I said before, one of the challenges in Openshift, or not in Openshift, when you have a distributed architecture, is the tracing of incoming requests. So we are going to install Jagger, which is a tool that is able to trace the incoming request for a particular application and give us some information about the request itself. So I am going to create a project that I am going to call user1 monitoring, in which I am going to install the Jagger tool. In order to deploy Jagger, we click the add button and we try to find YAML, and we're going to specify what we want to deploy. So the kind of what we want to deploy is Jagger. We also need to specify the API version. This is very important. It's going to be Jagger tracing.io/v1. And we also need to include a name of the Jagger that we're going to have, which is going to be all in one in memory, let's say. So if I did something wrong, what is wrong? I did something wrong, great. Let's go here. What is happening? Monitoring. Let's go back to the console, go to the monitoring namespace. I'm going to check the events of the namespace. Okay, nothing here. So we're going to get the Jagger, and it is running according to this. So what was wrong? Let's check the pods now. It is running. So it should be some eventual error. So if we go to the networking now and we're trying to find the route, we need to log in with the Openshift user that we have and allow the access to the permissions. Okay, so this is the Jagger UI. Right now it's empty, but because we need to configure some applications to integrate with the Jagger, that is what we're going to do with the inventory service. Also mind that this is not the recommended way of installing Jagger because it has everything in memory. So if you are going to install Jagger and you don't want to lose any information when the application goes down, when the Jagger application goes down, you should not install everything in memory. If, for example, the Jagger application goes out of memory or the pods get evicted for some reason, you will lose all the tracing information that you have. So this is okay even for a dev environment if you want to have a tracing tool. But if you're going to deploy that and you want that in a more production namespace, it is not recommended to install the all-in-one. So we are going to add the Jagger integration with the inventory application. So back to the code-ready workspaces, to the file explorer. I am on the inventory application. If you remember correctly, the Quarkus framework requires an extension to work because of its particularities. So the first thing we need to add to integrate Jagger is to add an extension to the application, which can be done with a Maven command. So we need to use Quarkus and the call add extension, and then we need to specify the extensions that we need to add. And the extension is going to be small open tracing. And that's all that we need. If we click play, we can see that the extension has been installed. This means if we go to the POM file again, that if I try to find small open tracing, is going to be added as a dependency here. It is possible to include it as a Maven command, or you can go to the POM file and include it as a dependency. Okay, so what we need to do now is, first of all, verify that the Jagger collector is being configured in the Jagger application. So if we go back to Openshift in the monitoring namespace, we can see the services that are exposed by the Jagger application. And one of them should be named Jagger all-in-one in memory collector. And we want, let's check this YAML, and we want this one. We are going to communicate with this port. If your application is using another library for the open tracing integration, you may need to use a different one in this particular scenario. So what we need to do is to include the Jagger configuration. So I am going to copy all this service name because we are going to need it. And in the inventory application, if we go to resources and application.properties, we can go and configure the inventory integration. So the inventory integration with the Jagger. Since we have added that particular dependency, we only need to add some properties here. So we will add some properties for the Jagger configuration in the prod profile because we want it only to prod. So prod.quarkus. First of all, Jagger.service name. Service name is not the Jagger service name, is the service name of the applications that we are running, which is going to be inventory because we are on the inventory application. Another thing we need to consider is the Jagger sampler type, which is going to be const. So the sampler can have different configurations. The one that I am configuring, which is constant, it means that it is either going to take into consideration all the requests or no request. It is also possible to specify some other differences in the sampler configuration, but the easier one is trace everything that is going into the application, which is what I am doing in this configuration here. And finally, we will need to specify the Jagger endpoint, which is going to be HTTP. Oh, no. Then this name, which is the service name. And now we will need to add the namespace in which the Jagger is running, which is the monitoring namespace in my case, and then add .svc.cluster.local, which is the full service name, which can be used in all the namespaces. And then the port that was 14268. So we'll go here. And then we need to add the path API traces. Okay, so this is all we need to integrate a Quarkus application with Jagger tracing. And now what we need to do is we need to deploy the application. So we need to do a Maven clean package. I'm going to skip the tests. And it should be able to deploy the inventory application. Let's go to the application. It should be able to create the new image in which its production configuration is going to have Jagger include. So it is possible to trace the incoming requests. This particular tracing configuration becomes very interesting when you have multiple applications and you want to know for a given input request to your service, how much services it is calling, how much time it is taking in the other services, how much time is taken into your service. So identify bottlenecks and sometimes excessive external calls. This tracing tool is very useful. So now it is building the image. And if we give it some time, it should be start deploying. Don't forget that in the module 1, we added some configuration to the POM file that enables the creation of the image when we do a Maven clean package. So it's not something that is done automatically. If you have any doubt about how the Quarkus application is being deployed, you can check the module 1, or you can ask me any question that you want. Okay, so the Quarkus application has been built and now it should be deployed somewhere. So let's go back to the developer view. It is already deployed. I don't think so. Yeah, it's not deployed. What is happening here? Let's go into the request. Should be. What is happening? Services, inventory. Okay, maybe because it's HTTP. Yeah. And in the Jagger, no inventory. It should appear here like a different service, so you can filter by service. This is the Jagger query service, but it is not what we want. We want the inventory service. So let's check what is happening here. Okay. This is weird. This has not been redeployed. So the inventory has been running for some time now. So this pod is not possible to have the image that we have built right now. So let's go to the images now. Inventory. Yeah. What is happening? Oh, I had. In which project am I? Oh, monitoring. Great. So one thing is that I did the Maven clean and it deployed the inventory application. But since my OC command line was connected to the monitoring project, it publishes the image to the monitoring namespace. We don't want that, so I'm going to delete the image string inventory, and I'm going to move to the inventory project, and I am going to build again. So now now we should see a new image here with a different timestamp that is not 45 minutes ago. These little problems, namespaces, configuration, images, seem to be very difficult at the beginning because there are a lot of different elements to consider. But at the very same time, each element has its own responsibility. So it's very easy to try to find where the problem is. So right now I am building the application, and it should now deploy to the expected namespace, which is the inventory namespace. So we go now to the pods. Okay, the build seems to be running. And let's see. Okay, it is building the image now, and it should be building, let's hope, yeah, in the expected namespace. So when this image is completed, there you go, a new deployment is created. The image has been completed. There is a new image available. So a new inventory should be created. So let's go to the pods now and trying to find, yeah, this one is the pod that we want. So if I go to the deployment config and I go to inventory and I check its pods, I can see that there are two of them right now. The one without Jagger, which is inventory 1, and the one with Jagger, which is inventory 3. This number here is bound to the deployment version, to the deployment config version. So each change that you do to the deployment version, you will have a new number here. And all the pods of the same version should have the same number. So when this one becomes ready, this one will be terminated. And now if we do the same request again, we should be able to see some information in the jar. What this protocol is this using? Okay. Now we refresh the Jagger page, and now we can see that there are two services. One of them is the inventory, in which if I find traces, I can see a lot of them. These are all the requests I have executed to the inventory, to the get all method in the inventory resource component. And if you can see here, it says that it has one span and the inventory service has one span. That means that this request goes through one, or it only has one service involved, which is the inventory service with one call. If we have another service involved, we can see, for example, two spans here, an inventory service and catalog service, and we can see how much time it consumes in each of the services. So if I go ahead and I click this here, I can see a lot of useful information like the URL that is being called, response status code, Jagger metadata, as you can see here, and also how much time it took. It is also possible to filter, like for example, by status code. This could be http.status code equals 300. Where is the filter? Let me go ahead and try to expand the filter. 100. Oh, it could be on search, maybe. Yeah, it is on search. So go here and you click status code equals 200, and we can see all of them. And we change a different one. There is none of them. Yeah, it doesn't make sense to filter a status code for a particular request because there is only one. But in this case, which is what we are filtering all the inventory requests, we can, for example, if we want to get, I don't know, all 4 at once, so we just change this status code. Or it's also possible to filter by duration of the request processing time. So this is useful for the tracing of incoming requests, but one thing to consider when deploying to Openshift is the monitoring of the applications itself. In order to monitor performance and resource consumption, we'll need to deploy, first of all, Prometheus, and second of all, a Grafana dashboard. So back to the Openshift console, we can go to the monitoring namespace. And we will need to, I will go to the developer view, and we will need to add a new deployment, which is going to be container image. So what we're going to deploy first is Prometheus. So Prometheus is on quay.io/Prometheus. And the application name is going to be Prometheus app. And create application Prometheus app. Yeah, and the name can be Prometheus, and yeah, everything can be gateway timeout. Okay, so Prometheus is starting now. I'm going to open the URL. So Prometheus is a tool in which we have all the application metrics, and it's able to collect all of them. And we can do queries like, I don't know how many queries can we do here. Let's see. Process start time, Prometheus, engine queries, etc. It depends on the metrics that our application is exposed. And Prometheus is able to query them. It's able to collect them, and then you can do queries on them. So the problem is that Prometheus is not very usable because you need to write all different queries. So what can be done is we can deploy Grafana. We can configure Prometheus as a data source for the Grafana dashboard UI, and then create a new panel with a Prometheus query that is going to show all the information in a more user-friendly way. So we will need to deploy Grafana. So we will need to do the same. We click add and then container image, and we are going to include maybe Grafana and /Grafana latest, and then we we are going to create an application, and we are going to call it Grafana app, and the name is going to be Grafana, and yeah, it can be a deployment. Okay, so the Grafana is a dashboard, it's a UI that we need to configure in order to be integrated with the Prometheus data source. So by default, the password is admin. new password. I'm going to set up, I'm going to skip it. And first of all, we will need to add the Prometheus data source. So Grafana can connect to Prometheus. So when we create a new dashboard in Grafana, we can include a Prometheus query. So we click on data source here and we select Prometheus. And we need to include the Prometheus integration, which we need to add the name of the application, which is Prometheus, and then user one monitoring. And the port is going to be 9090. If we click save and test, data source is working and everything seems to be okay. The problem right now is that the service is not exposing any metrics, which means that even if we create a dashboard in the Grafana, we will not be able to see any information because we'll need to consume the application metrics. In order to do that in a similar way that what we did with the Jagger, we will need to add an extension to the inventory Quarkus application. So if I go back to the code ready namespaces into the terminal, I need to add an extension. And the extension is going to be micrometer hyphen registry hyphen Prometheus, and then we click enter. This is going to add that dependency to the POM file. And then what we are going to do is we are going to include some metrics in the application, and we can configure some dashboards in the Grafana. In order to configure the micrometer, what we need to do in the inventory resource is to add a meter registry. No suggestion. Okay. I'm going to do the cannot be resolved to a type. Why not? I'm going to import it manually. Port io.micrometer.core.instrument.meter registry. I don't know why it is not getting it. Okay. Now, yeah, we need to include the default constructor because we cannot define a final variable without being initialized. So we're going to have a meter registry, which is going to be registry. And just we are going to set the field to the registry parameter value. Okay, so this registry is a tool that we can use to add some metrics to the application. So if I go here and, for example, in the get all service, I do a counter, and then we need to specify some name, which is going to be dot counter, and then just increment. So it is going to be incremented for the request, and then we are going to include a timer. It's going to be inventory dot performed checks all dot timer, and then we will be able to query these metrics that we are creating here. Then we are just at 3000, and the time unit is going to be milliseconds, so 30 seconds. Hope. So in order to, what is the problem now? Oh, time unit is not being resolved. Okay. So we need to import the time unit as well. So as we did with the meter registry, it is going to be java.util.concurrent.timeUnit. And now it should be, yeah, it is okay. So I'm going to do a clean package, skipping the test. Let's see if this works. And by doing this, basically what we're doing is we are adding these metrics to the application metrics, so we can have, or we are able to check these particular metrics. But we can, there are also some other metrics that can be used by default. Like for example, I don't know, the memory being consumed by the application. After adding these custom metrics and building the application, since now I should be on the inventory project, it should be able to deploy the application with the metrics. And when it is deployed, we can query the application for its metrics value. So let's wait until it is connected. Okay, let's go back to the Openshift inventory project. Okay, we need to wait a little bit. Okay, something went wrong. Let's see if it is building the app. Nope. What happened? It seems that I am still logging. Data connection has been closed by, so I'm going to try again. Okay. Application is been building. And okay. The Maven plugin should be able to to build the image as it did before. Well, the Maven plugin doesn't actually build the image. The image is built in Openshift. Okay. I think I did something wrong. Oh no, there is a new build here. So it should. Okay. Okay, so now we get the builds. There is one completed. And if we check the pods now, there should be a new deployment of the inventory service because there is a new image. And since the image trigger is configured, yeah, a new deployment is started. And this inventory application should have the metrics already exposed. Let's give it a moment to be. This 0 out of 1 means containers inside the pod. When we have 1 out of 1, it means that the application is ready. It is possible to enter a container by the command rsh. So and use the pod name. And since it only has one container, we are right now into the inventory container. So if I do a curl to HTTP localhost 8080 and then q/metrics, I see some metrics back. These are the metrics that Prometheus is going to collect and that we are going to display in Grafana. As you can see, there are like JVM used by some very useful memories that are being exposed by this container itself. So I'm going to exit here. And right now we have Prometheus deployed and also Grafana in the Openshift cluster, and the application is exposing its metrics. What we need to do now is to configure Prometheus to consume the application metrics. So it's able to do the same HTTP query that we just did. In order to do that, we can go back to the Openshift cluster, to the monitoring namespace, and we will need to add a config map, which is a configuration element. So we click add and then from YAML. And the kind that we're going to add is a config map. API version, it is v1. Then its name is going to be Prometheus config. Then inside the config map, we are going to have a Prometheus.yaml in which we are going to configure all the scraping configuration. So in this Prometheus.yaml key, we are going to include a YAML file, which is going to be scrape configs. Then we are going to include Prometheus, first of all, and static configs. And then we specify the target here. It's going to be an array of localhost 9090. This is Prometheus itself. And then we are going to add another one, which is going to be inventory Quarkus. And then we need to include the metrics path, same as we did with the call metrics, q/metrics. And we need to also include in the static configs the targets, which is going to be, well, the endpoint, which if I go back here and I do, yeah, it's just inventory, the service name. So in Prometheus, it should be inventory.user1 inventory, because inventory service is running on the inventory namespace. .svc.cluster.local, and the port is 8080 because it's what we are using on the application by default. So I'm going to create this config map. Metadata. Okay. So this config map here has a YAML, but Prometheus does not know how to load this config map. We will need to specify that. When we load or we mount this config map into the Prometheus container, we are going to have a Prometheus.yaml file inside the Prometheus container, which its content is going to be this one. In order to do that, it can be done in the command line. I'm going to move to the monitoring namespace first. I'm going to check the pods. Okay, Prometheus is running. So we need to set a volume. So OC set volume on the deployment that is named Prometheus. And we need to include, that is an addition of type config map. And then we need to include the config map name, which is Prometheus config. And then we need to include the mount path, which is here. All the things that I am doing with the command line can be done in the YAML specification. I will show you just when it is mounted properly. The Prometheus YAML. Okay. So the deployment is updated. The pod is creating a new one. Okay. So if now we go to the Prometheus YAML, so we go to deployments and Prometheus, and then to the YAML tab, and I try to find Prometheus config, I can see that it's configured as a volume. That is, where is it mounted? Into this path here. If this is correct, so we could go get this and modify the YAML directly. We don't need to do any OC command. But if it is this correct, if we go to the pod and then we go into the terminal, if we go down to the route in which the config mat is mounted, we can see that there is a file which is called prometheus.yaml. And if we check its content, it has the configuration we just created on the config map. If this configuration has to be changed, you can go to the config map, add something like a new job, and then go to Prometheus and redeploy, and it will get the changes from the config map. That you don't need to modify the Prometheus each time you modify the config map. But since we were mounting it for the first time, we need to do that. So this is configured. I am going to do some request to the inventory service. So where is the here? So I'm doing some HTTP requests, and if we go to here, let me go and refresh this. Now we can see the custom metrics that we included. Inventory counter total 6. We can see that the job is inventory Quarkus, and the instance, which means the target that we have configured. Now the good thing is that these custom metrics cannot be, if I, for example, ask a new one, I will need to go and do the query again. But in Grafana, we can add a dashboard. We can add a dashboard that is going to do the query for us, and it's going to show a graphic view of the application metrics. So we're going to add a dashboard and empty panel. And we need to add some title, maybe we're going to add maybe the query first. So data source is Prometheus. This is important. And we need to do for example, this one. And we're going to add a title, which is inventory metrics, for example. Well, the time range is going to be like 5 minutes. So we can see like it goes increasing each time. And if we click the button, it will go and refresh the dashboard. So we click apply, and then we have a dashboard here in which we can see the inventory metrics in lifetime. Just we can go and refresh the dashboard, and it is going to do it for us. Now it's been refreshing it by itself. Another metrics that we could add to the Grafana dashboards is the memory usage of the application itself. So if we can go and add a new panel, an empty panel, and instead of being, we are going to add the memory consumption. So instead of being a time series, it should be, where is it? Yeah, this one. Okay. And in the metrics, we are going to add a default metric, not one that we have included, which is the memory. And then on the panel, we are going to say that it is memory. And we will need to try to find now the units. Where is the unit? Should be bytes. Yeah, there you go. So if we click apply, we can see now the metrics of this application here, the memory that is being consumed and the incoming requests of the application. If new applications has to be added to a dashboard, we will need to either to include new panels, or we can also group the queries by, for example, application, and then filter by have the same query. But at the same time, we will need to go to the Prometheus config map in here, Prometheus config, and add a new config. For example, for a new job name. If we want to include configuration for the Spring Boot application, for the Spring Boot application that we have running in the catalog namespace, we will need to go to this config map and add a new scrape config. And with this Prometheus and Grafana configuration, we have concluded all the tasks that we wanted to do today. So to resume all the configurations that we have done in the workshop, first of all, we gone through the configuration of a continuous delivery pipeline in Openshift. We have done that by using a Jenkins pipeline strategy, and we got the image from a dev namespace and promoted it to a prod namespace within the same cluster. And we have also do some small modification to the pipeline and tried to simulate the promotion of a change from dev to prod, which was a CSS change, very simple change, but the process, it is the same, even if the change is more is larger. And we have also checked how to do debugging with the code-ready workspaces IDE. And finally, we have added some tools to the Openshift cluster, like the tracing tool, which we have used Jagger and all-in-one in memory solution. And we have configured the application to report these metrics to Jagger. And we have also deployed Prometheus and Grafana and configured some dashboards that collect the metrics from the application Prometheus endpoints. Mind that all these changes need to be configured in the application image. So it is not possible to deploy Jagger in Openshift if your application is not integrated with Jagger. It is not possible to have metrics of an application in Openshift if your application is not exposed in the metrics query. But at the very same time, there are libraries and there are utilities that makes this configuration very easy. As we can, as we saw with so little configuration, we could integrate with a tracing tool and with the Prometheus configuration. So before we wrap up this workshop, I would like to know if there are any questions or any item you may discuss before the workshop is finished. Okay, it seems that there are no questions. Even so, the workshop environment will be up and running for some time. So if you go through the guides yourself and you find a problem or you want to know more information, for example, how to configure Jagger tracing in a production configuration, like for example, not only memory, you can go and ask me, send me an email, and we can discuss the possible solutions to your workshop problems. Okay, so if there are no questions, I would like to thank everyone for your attendance today. We will have some more workshops coming on, so please check your email, so we will do the following workshops with you, which I think it is the service mesh. It is a very interesting tool. So we will keep you updated. Thank you very much, and see you on the next workshop.